talk about free functions in 2017. So do we have to really talk about free functions in 2017? So, there's too many Java guys, okay. I think in 1 hour you might agree, yes, we have to talk about free functions and we have to really talk about this. So trust me, I know from experience, from so many trainings I've given and from a lot of discussions with experts, free functions is something that is vastly underused. So yes, we definitely have to deal with free functions. So, I know this is a controversial topic, it may be a controversial topic. And so the first thing I probably ought to do is to establish some common ground, something that everybody can agree on. And so, I would like to ask you, what do you feel is important in software? But this would probably take too long. And so I've compiled a couple of metrics, attributes that you hopefully feel is important for good software. So the first argument I have on my list is encapsulation. So who feels encapsulation is something that is important? Okay, almost everybody. Encapsulation is important, isn't it? It doesn't work without, to some extent. Okay, next one, abstraction or polymorphism. Who feels this is something that you want to have in your software? Something valuable? Okay, perhaps a couple of less people, but still, yes, it is valuable, it is good. Cohesion. Things belong together. What do you feel about this? Is it great? Okay, most people agree. It is valuable too. This is something we're looking for. Flexibility and extensibility. Who feels this is important? Okay, now everybody's on board again. Of course. Of course this is important. Reuse or reusability. Okay, most people feel yes, of course. Else it's a pain. Testability. Okay, so I'm looking for the people who do not raise their hands. I would, yes, of course. We want to be able to test things easily. And of course, last but not least, performance. Who feels performance is important? Most people feel this is important. All right, we all agree this is something important, something that we should have, that we should introduce in our software in order to make it better. And now I'm absolutely bold. I'm starting with a hypothesis. I'm starting with the hypothesis that you might have seen before: prefer non-member, non-free functions. If you want to have the stuff that you just saw, prefer non-member, non-friend functions. And I have a couple of very compelling, hopefully compelling arguments for that. However, before I go to the arguments, I have to repeat something first. This is important for me to explain things, the solid principles. So, I ask in the reverse question, who is not familiar with the solid principles? Okay, very few hands. So, I go over it quickly. I have it on my slide anyway, so it's sequential slides, unfortunately. But I'm not saying a lot about it, so you definitely have to read it up. The first one is the single responsibility principle. Everything should be changed to only for one reason. Yeah? Everything should apply to one actor. This is the most correct formulation I know of. The second, the O in solid, is the open-close principle. Yeah? Your software should be open for extension, but closed for modification. It should be designed such that this is possible. The L is the list of substitution principle, which is basically about type substitutability. You want to be able to pass some derived class to some function that takes a point of reference to base type. The interface segregation principle. This is about the idea that the interfaces should introduce as few dependencies as possible. You should not overwhelm people with stuff that they don't need. It should be segregated to some extent. And the last one is the dependency inversion principle. This basically says, well, you don't want to depend on stuff directly, you should depend on abstraction. That's one of the basic ideas of, or perhaps the basic idea of object-oriented programming. All right. Now I have a couple of arguments to tell you why you should prefer non-member, non-friend functions. You want to see the argument, the first one? Yeah, of course you do. And I have to tell you, you will see it anyway, even if you don't want to. So, the first one is encapsulation. Yes, indeed, encapsulation is improved if you use free functions instead of member functions. This argument is perhaps a little surprising, but it's a very old argument. This is an argument that Scott Mice has written approximately 20 years ago, or has written about. And this was the example that he had. Yeah, Effective C++, third edition, if you look it up, he had a class called web browser. And this web browser has 3 public member functions. Clear cache, clear history, remove cookies. And it's of course a little unfortunate that you have to call all of them separately in order to clear everything, so let's add a clear everything function that is not doing anything but calling all the clean up functions. Okay, Scott says, yes, this is what you can do, but you could do something that is better. You could actually take this clear everything function, make it a free function. Of course, it changes slightly. Now it's past a non-const reference to web browser, but it can still do its job. It can call the 3 public member functions, and the effect in the end is exactly the same. So why should you do that? Well, his argument is because you actually improve the encapsulation of the class web browser. In the left example, clear everything can do everything. It's called clear everything, but it could do everything also. The state is not protected from this function because it's a member function. In the right example, clear everything can only use the public interface. And this is all it needs to do. It only needs to use the public interface. And so a little bit, the protection of your class is increased. The encapsulation is increased. And I know the worst thing I can do is to read long statements, but I feel the words that it shows are truly beautiful. And so I'll just read this. So a short extract from this particular item. Object-oriented principles dictate the data and the functions that operate on them should be bundled together. And that suggests that the member function is the better choice. Unfortunately, this suggestion is incorrect. It's based on a misunderstanding of what being object-oriented means. Object-oriented principles dictate that data should be as encapsulated as possible. Counterintuitively, the member function actually yields less encapsulation than the non-member. I don't know how you feel, but I feel this is actually a very strong argument. And yet I've talked to so many people that feel, okay, this is not really convincing. This is just one of so many things that I have to take care of. This is why I have more arguments, much more than Scott did. So the second argument that comes your way is coupling. And you know, coupling is essentially the prime enemy of us, the prime enemy for software development. We want to reduce coupling as much as possible for the overall maintainability, of course. Let's take a look at this example. I have a class X. It has a vector of integers in a private part, so it's probably encapsulated. This is nice. And it has to do something function that it can call in a public interface. One of the things that do something has to do is to reset the values. This is just part of this algorithm. So how do you do that? Well, of course, what I can do is I can add a private auxiliary function called reset values. It reverses the vector and sets all the values to 0. So, mark, it's not the clear function. Yeah, I don't want to change the size in any way. I just want to reset all the values to 0. This is the semantics that I see in reset. All right. Well, this is what you can do. Well, let's take a look at reset values, a little closer look. On how many things does reset value truly depend? How many dependencies do you see? Do you see one dependency? Do you see 2 dependencies? Okay, does someone even see more? Then I missed something. Okay. I see 2 dependencies. The first dependency is the one dependency that you see in the body of the function. It works with a vector. It cannot do this with something else. It's bound to the member variable. But there's another kind of invisible dependency. Which dependency do you not see? I'm sorry. This, absolutely correct. This pointer. Every member function has a pointer. This pointer. This is a dependency. Do I need x? Does this function really need an x? Actually, no. There is nothing in x that x really depends on. So what I should do in order to reduce coupling is I should implement it as a free function. Reset values, of course, now it gets a parameter, again, a reference to non-const, vector of int reference, and it's doing exactly the same thing. Now, do something simply calls a free function. Nothing changes. No encapsulation is broken or anything. Nothing changes, but the reset values function is suddenly coupling to only one thing. And this is now clearly visible in the interface of the function. This is a good thing too. Okay, I look into your eyes and you are not particularly happy. Okay, so perhaps I have to tell you a little more about this decoupling. So what did we truly do? The first thing that we did just now is we actually followed the SRP, the single responsibility principle. In this particular case, is this reset value, so reset value is again being a member function, is this truly something that the class has to do? Is this a service of the class? Is this something that really needs to be inside? I don't think so. This is just some extra stuff. And it kind of disturbs the overall responsibility of the class. If I move it out, if I make it a free function, suddenly the class is much more focused on its actual task. And it uses a couple of other services, yes, for instance, reset values. This is good. From a design point of view, this is actually truly good. SRP is important. But it's not the only thing we've done. We actually have also followed the open-close principle. Now, open-close is actually, well, the foundation of proper object-oriented programming. By introducing the free function, what we have now done is we have vastly increased the flexibility and the extensibility of our software. Okay, rhetoric question. I know it might be a little too simple, but have you ever tried to add a member function to standard vector? Well, no, of course not. You cannot add a member function to someone else's class. But did you realize that you can extend the functionality of standard vector by adding a free function? And this is quite trivial. We've just done that. Reset values essentially extends standard vector. And we can always do that. You can add free functions to your own stuff. You can add free functions to your colleague's stuff, but you can also add free functions to stuff of the types of the standard library. This is amazing. You probably didn't realize this before, but this is a huge increase of flexibility and extensibility. Oh yeah. You're still tired from the party yesterday, right? I would actually expect a couple of more happy faces. Oh yeah, this is actually really, really great. Okay, so you need more arguments. I realize that. Okay, here's another one. Reuse. Essentially the dry principle. Don't repeat yourself. Okay, imagine that we have another class Y. Okay. I know this is now a little far stretched. Yeah, I know usually we all have just one class and squeeze our stuff in this one class, I know. But just for the sake of this one example, assume that we have a second class Y. It's cleverly also having a standard vector of integers. This one is called indices. And of course, yeah, it also needs to reset those indices. So how do that? Now imagine I have implemented reset values as a member function of X in the private part. How to reuse that? There is no reuse. And so I end up implementing the same logic again. Very likely as another private member function of Y. What a waste. What a shame. However, since we have decided to make reset values a free function, we can reuse it. It is only a small function, but still, this logic is not duplicated. This service is available to everybody who wants to use it. This is, again, a good thing. And I don't know if you remember the quote from Robert Martin who said, duplication is the root of all evil in software. Actually, this is a very, very easy way to reduce duplication. This is good also. Now, imagine there's a bug in there. Okay, again, assuming it's a little more complicated, you could fix it in one place, but not two. Again, a really, really great argument. Are you convinced? Who's convinced? Oh, okay. This is a little more than I expected. Okay, but still, I assume there is a couple of people who are objecting the idea. I have one more. I have one more argument. So, reset values. Reset values is a name that is a little unfortunate in this context. I have a class Y, I have indices, and I have to call reset values. The name is not good, right? And so the first thing that I probably should do now is to choose a better name of the function. Yeah, naming is hard, this is true. In this case, it might be a little easier, because it's an easy function. Reset. This is reusable also. This is good. Now that I have chosen a better name, what can I do? Okay, I missed one other point. Actually, so assume in your library you have a different kind of reset. So you're not calling it reset, you call it reinitialize. Could you rename a member function? No, you cannot. Can you rename a free function? Yes, you can. Reinitialize is the renamed reset. Of course, it's just a wraparound reset, but you can rename things. Flexibility. Also, extensibility. Very good. All right. Overloading. So, in my trainings, I'm usually asking the question, how is dynamic polymorphism implemented in C++? What do I have to do? And within seconds, somebody says, virtual. Correct. Bonus point. The virtual keyword gives us dynamic polymorphism. Great. How is static polymorphism realized in C++? So, within CRTP. So, within a split of a second, somebody says templates. Yes, correct. And what else? Not CRTP. Exactly, function overloading. For some reason, people are not realizing that there is a second static polymorphism mechanism in the language. It's called function overloading. This is static polymorphism too. And I can use this in this particular case in a very, very nice way. Look at the red line, value equal to 0. I'm hard coding what it means to reset an integer. I don't particularly like this. This is, well, it can definitely improve on that. And how? By simply moving this out of the function. And how do you call the function? Reset. What does it mean to reset an integer? Well, I can encode this in a function called reset. It takes a non-constant reference to an integer. It's encoded there. And reset for a vector, it simply calls reset on the value. You definitely should look a little more happy. This is truly great. Because I'm now building on free functions, what you can do here is basically you can reset everything. Okay, there's one thing missing. It's basically screaming at you. What do I have to do now? It's just one tiny step. So, different values. Templatize. Generic programming. Yes. What should I do? I should make the reset function for a vector a template. Yes, I can of course templatize much more, make it more general. You get the point. I make this a template. I am now traversing t's. I have no idea what t is. What does it mean to reset a t? It means to call the reset function on the value. Does it work? Well, in this case, it does work because I have a reset function for an int. What if you give me a double? Well, okay, it might actually accidentally work because it's convertible to, it's a reference, right? So you just write a free function yourself. Yeah, you give me a vector of strings, I can implement a free function. I don't have to touch the string class. It's not a member function that I need a free function. You can add a free function to virtually everything. This is, again, an amazing flexibility. Oh, it is beautiful, isn't it? It truly is beautiful. I don't know what to say. I don't know if you're aware of this, but what we've just added is abstraction. And perhaps you don't value it enough. Abstraction is basically the one thing that object-oriented programming gives it that works really well. This is the core idea, the core value of object-oriented programming. How did it get there? By a free function. This is amazing, isn't it? Okay, and still there's people who look like they've partied too long. So you need more, apparently. You are not fully convinced that this is the thing that you should do. Okay, I give you that. You need one more. And this is an important one. And hopefully after that, everybody believes me, it is something that you should strive for. Testability. I claim a free function is much better in terms of testing than any member function could be, for various reasons. Okay, let's go back to the initial example that I had. I just called the function reset. We had a private member function. And then if you have something like this, something strange occurs, people are asking themselves, how can I test this function? So let's assume we have to test it. Yes, I know it's a little too trivial perhaps, but let's assume we need to test. How do I test this thing? Well, how do I find out how to best do this? Yeah, of course. Go to Google, C++, private member function testing. And you immediately go to some Stack Overflow discussion that tries to give you good advice on how to test this thing. Yeah, definitely, at least two particular threads. So the first guy that answers this is very likely tending to give this answer. Why not add a friend here? Friend in test reset. And it is a little sad to tell you this is usually the answer that is marked with a yes, this did solve my problem. So if you take one thing away from this talk, I hope it's actually a little more, but if it's just one thing that you can remember, please never do this. Yes, I know Google Test has this feature, and it's called feature. It's not really a feature. It's an anti-idiom. You're coupling your tests into your production code. Please don't do this. Please don't do this. This is not great. But okay, there is at least one guy who's even cleverer than this guy. And he gives you another answer that is even easier. Define private public. If this is a solution for you, then this is a sure sign there is a flaw in your design. You're bending backwards in order to test a function in the private part of a class. Why did you put this function in the private part of the class if it is so important that you need to test it? Why? Why not simply making this a free function? There is no dependency here. You can test this very easily. You don't even need X. It's independent of X. I said we decoupled before. It's so much easier, and it's usually a great solution. Sometimes, of course, it doesn't work. Sometimes it has to be a member function. If you need to test it and it's a member function, please don't put it in private part. This is the least I am asking for of you. But a free function is even better. Okay. And I have to admit, this is not the most convincing argument. It's not even the last argument. There is one more argument that tops this one. The final one, the strongest one. What could you give a C++ programmer that even tops testability? Performance. Oh yes. Yes, I know this is now an argument that does not always apply, but it does in many cases. And I learned this myself 2 years ago at meeting C++, 2015, in the keynote of Chandler Carruth. Chandler is working in the LLVM team, and he likes to optimize things. He is obsessed with performance. This is what he says of himself. And this is the example that he presented to the audience. On the left-hand side, you have a struct S, and it's very lean. So it has a couple of float data members, it has a double data member, and a compute function, member function. And at some point you use this. So in a double F, you create an S, you do some expensive computations for the float data members, you compute the delta, and then you call S compute. So And still he complained. He complained because he says this is something that far too often occurs in performance-critical sections of code. And unfortunately, he cannot optimize this. Or LLVM cannot do this, of course. But he would like to do it by LLVM, but he cannot give you maximum performance. Why not? What is in the way of the compiler in this example? So it's not about the definition. Correct, it's about the this pointer again. The this pointer of the member function. Every member function has a this pointer. And it's an address. It's something that needs to be valid. In the f function, the optimal way to optimize all this would be to don't even have an s. I could keep all of this stuff in the registers, but I need an s. Where is the s? Well, it's in memory. And so suddenly I have to deal with memory. And this is what makes it slower. Without the this pointer, however, I note that I'm passing by value, not by reference. Everything runs more efficient, can run more efficient. I don't say it's always applying. In this example, it probably did. Yeah, this is what Chandler told us. The free function actually solved a performance problem. Now you should be absolutely convinced. Free functions are basically superior in virtually every way that we could have. Encapsulation, cohesion, flexibility and extensibility, reuse, overloading, generic programming, abstraction, testability, and last but not least, performance. This is an amazing list of attributes. This is virtually everything that I could come up with. Every single thing that you're looking for is in here, somehow. And you gain all of this by preferring free functions. Okay, now is the time to release this inner pressure that you must have. So for all the free functions advocates, so yeah, come on. Yeah! Okay, very good. Okay, now I know a couple of guys hate me right now. How can this guy stand up there and tell us about free functions? Well, this is, of course, an object-oriented programming language. Member functions are the primary vehicle of this, right? So a couple of guys are not happy at all, and these guys, of course, try to subvert all the arguments that I just presented. They come up with counter-arguments. Is this even a real idea? Is it used anywhere? Okay, this is a good question. Is it used anywhere? So you want to hear examples. You want to hear great examples. It's used here and here and here and here. I cannot show you everything, but I can show you one thing. Perhaps you feel this is convincing. This idea is actually used in the standard library itself. So let me show you two things that I simply feel are beautiful. The begin function. All of you knows that every container has a member function called begin, and of course end and so on. Hopefully you've noticed that in C++11 they have added a free begin function. Yeah? So in combination, so this is basically the overloads for the free begin function, and cbegin also. Very, very well. The begin function is not bad, so the member function is not bad, because every container has begin, and this gives you some kind of polymorphism, some abstraction. This function, however, this works on every possible type. For instance, there is an overload for static arrays. This overload is the only way how you can, with iterators, polymorphically in generic code, traverse an array of n elements. I could not do this with a member function because there is no member function on a static array. This is huge. This increases my genericism, my abstraction tenfold. You don't have, so you use standard begin, you your container doesn't have this, well, add it as a free function because you always can add a free function. This is huge. This is a real step forward. And there's another one, very similar, stood real on complex numbers. So how is a complex numbers implemented? Take a look at standard complex. It has more or less two members. They're called real and they're called IMAC, to get getters. Yeah? But they have also free functions called real and IMAC. Because this is needed in generic code. I get some type. It can be a double, it can be a float, it can be a complex double, it can be a complex float. How do I work with this type? How do I access the real part? I need a free function. Generic programming without the free function is virtually impossible, or a pain in the ass, one of the two. I need this. This is really, really powerful and really beautiful. I hope this answers the question. Where is it used? We are already using it. Okay, but still some people are not happy, not satisfied. They have another counter-argument. Come on, this is just a reset function. What does this prove? Okay, first of all, note there's a just in the sentence. And we learned in Kate's talk that if there is a just, it's probably wrong. But of course, yes, I know what the problem is. It's a very small function. It's tiny. It's trivial. And this might make you believe that there is actually, this actually does only apply to small and trivial functions. Okay, let's get rid of the function body, because I think this is what is disturbing. So now we have just the function. Why does this work so well for reset? Why am I able to overload? Why am I able to finally make it generic? Why is this working so well? There's two reasons for that. The first reason is it is doing one thing and one thing only. It is just resetting all the values. This is important because it only does only one thing. It is easier, much easier to find a name. And this is, it has clear semantics. Reset. Reset is something that I can reuse. Reset is something I can build on, that I can overload. So because it has these two properties, clear semantics and it's doing only one thing, it works so well. If you now have functions that do not have these properties, it might not work so well, I admit. If you have a function that is doing multiple things and it does not have a clear semantic where you cannot even find a proper type, a proper name, then the best thing is you probably should move it to some place I don't see it. Yeah, the private part of a class applies. This function, however, it works beautifully. And so it should be a free function. Only then you can truly benefit from all the advantages. So it's not that it's a small and trivial function. It also applies to longer functions, but they have to have certain properties. This is true. But functions should be encapsulated. Who thinks that functions should be encapsulated? Okay, no one. Okay, few people that now realize I will dispute this argument also. Well, the reset values function from the beginning. Now back to the very beginning. This function, is it truly properly encapsulated? Perhaps I should ask another question first. Why do we put it in the private part of class? Probably that nobody can use it, right? Nobody should call it. It's an implementation detail after all. Okay. Well, basically we have to protect from, could possibly protect from two kinds of errors. There's two kinds of errors. There's Murphy errors. Somebody wants to do the right thing, but unfortunately fails, usually due to bad interfaces. This is something that we have definitely protect against. We have to design our interface such that this thing does not work. Yeah, so that he cannot misuse our stuff. Scott named this, make things easy to use correctly and hard to use incorrectly. The universal design guideline. There's another kind of error. This is the Machiavelli errors. Errors where somebody tries to break your stuff, where somebody wants to misuse it. You cannot protect from this kind of error. Yeah? Remember, define private public. If I want to call it, I'll call it. There's no problem at all. So do I really have to put it in a private part of a class, which makes my life potentially less easy? I cannot test it anymore. I cannot really reuse it, etc., etc. Well, I believe there's no such thing as function encapsulation. This function should be a free function. And if you don't want somebody to call it, put it in a namespace. Put it in a namespace that is, for instance, called detail. This is the convention Boost. Boost is the detail namespace, and everybody knows this is the implementation details. Nobody will accidentally call the details. This is good. This is all you need. This is what you need to protect against. This here is not real protection. And I can even prove that this is not real protection. Yeah, this gives you the illusion of encapsulation. It is not. It is a broken encapsulation. So, in order to show you this, first we'll move it outside again. Now it's a free function, and then it's gone. Where's the function gone? To the source file. If I really want to encapsulate things, make it a free function, move it to the source file. Sometimes it's not possible, of course, but sometimes, very often actually, it is possible. Now, it's not mentioned in the header file anymore. Still, people can call it if they really, really want to, but it's much harder. But you have no dependencies. You're at decreasing dependencies again. And this is good. So, full protection. I should remark, this is actually also something getting to do in C. Yeah, this is what people did in C back then in order to encapsulate things. So C encapsulation is actually better than what we call encapsulation. Yeah? Think about this. This is interesting. IDEs don't help with free functions, but with member functions. Okay, yeah, this was an expected argument, of course. Virtually all IDEs help you with member function. Yeah, you have a string S, you say S dot, and you listed all the 150 member functions of a string. This is great, it helps. If you have a free function though, you're on your own. Find the member function yourself. That's a pity. That is actually true. And I have to say this is truly a disadvantage at this point in time. However, perhaps you remember that there was a proposal. There was actually two proposals, two ideas being the same idea that tried to improve the situation. Anybody recalls unified call syntax? So a couple of people might. It did not work out. Today we do not have unified call syntax for some reason. So I'm reading you now a blog post by Bjarne, and this might explain why we do not have it today. Note begin C and C dot begin for ranged for loops and in general code. Why do we, someone, have to write both? If C dot begin exists, begin C should find it, just as X plus Y finds the right implementation. In early 2014, Herb Sutter and I each independently decided to propose a unified syntax. To my surprise, many people came out strongly against X.fy finding fxy, even if member functions were preferred over the freestanding functions by the lookup rules. I received email accusing me of selling out to the OO crowd. Whew. Okay, this might give you an idea that this was a very heated discussion. I don't know if it's finished or if it's still ongoing. I don't know. But you realize, actually, this would be valuable. If you could type x.f and it would pick up the free function that you have preferred because it's better, a lot of problems would be solved. It's a shame, I know. So, what you have to do, after you leave this room, go to your vendors, to your IDE vendors, and ask them, what can you do in order to enable me to use free functions in a better way? Some IDEs actually provide it, so I cannot advertise anything here, but try some things. Actually, it is possible. However, there's something more. X.f and f of x gives you the idea that these two things are different, right? There's a very nice quote from a very brand new book. I got my copy this week by Robert Merton. But just what is OO? One answer to the question is the combination of data and function. Although often cited, this is a very unsatisfying answer because it implies that O.f is something different from f of O. This is absurd. And I agree. I've just presented you so many advantages, all the things that you expect from object-oriented programming, and you find this in free functions. Why should I have to type out of F? Okay, I don't know. Okay. You have another good argument, a very good one. I cannot mock a free function. Okay, so this is what a couple of people here have waited for, right? Of course, mocking. How could I forget about mocking? Well, first of all, this implies that I have virtual functions also, right? So virtual functions cannot be made free function. I hope this is clear. But is this truly a downside? Is this something that you need so desperately that you have to revert to member functions again? Well, consider the following idea. I'm pretty sure that what you're mostly doing is you're implementing business logic. Very few people sit down the entire day and type data structures. I think most people are actually typing business logic. And business logic is some things that are algorithm-like. And algorithms, like in standard library, can be implemented as a free function. Now, if you have a virtual function, virtual behavior, if you want to dispatch this algorithm virtually, what you can do is, well, you can implement the business logic in a free function. And a virtual function merely calls a free function. It's not a big step. However, what does this make X? X is nothing more but a dispatcher. And this kind of dispatch is what you usually find in stubs and mocks. So suddenly your production code becomes your testing code also to some extent. It does not always work, but very often again it does work. And so you actually don't need extra stubbing, extra mocking. This may actually work very well in your favor too. Yeah, I know, free functions are just so amazing, aren't they? So, okay, still a couple of people are not happy. Does this mean we should convert to functional programming? Okay, so some people might have misunderstood what I'm talking about. So no, this is not about functional programming. So I'm using free functions, right? But this is not functional programming. So is this reset function a functional programming function? It's not. It is violating the basic rules of functional programming. It is manipulating data. Yeah? It is passing a non-const reference to vector. This is definitely far away from functional programming. Or is it far away? Well, okay, some people might have thought this is a very good counter-argument, but perhaps you have accidentally tripped over another positive aspect of free functions. Multiparadigm. I believe free functions is the one feature that you can use across all paradigms. Function programming, object-oriented programming, structured programming, everything. Yeah, and so if you use free functions, you're actually in the position to very easily switch between paradigms. Here's a little bit of OO, here's a little bit of functional programming. It works miraculously in one code base. You can take the best of everything by just using free functions. Isn't this truly amazing? Oh. Okay, you can thank me later. Should we avoid member functions entirely? Okay, this is actually a serious question. You might get the idea that I'm telling you you should basically make your classes containers for data. And everything else is, of course, now a free function. No member functions anymore. No. If you quote me like this, yeah, you have to use free functions, I will tell you, no, this is not the right quote. What I'm telling you is prefer free functions, not use them exclusively. There are situations where we have to use a member function. There are situations where the free function is just vastly superior. You're the experts. You should choose. You should not have only member functions. You should not only have free functions. The right mix of things is, of course, the right thing, the compromise. And along with all the other arguments that Scott have, he had also a very nice kind of algorithm to help you decide when to use a free function. So, if f needs to be a virtual function, okay, obviously for technical reasons it must be a member function. Make it f a member of C. Else if f is the output or input operator, or if f needs type conversion on its leftmost argument. This, for instance, happens if you have addition, subtraction, etc. Then make it a non-member function. If f needs access to non-public members of C, okay, this might be the one exception where you add a friend. A friend is not usually a friend in C++, you know that. But this may be a good thing. So don't make it a member function because it needs to have access. Make it a free function. This is what people want to use. This is what people want to see, especially the people that write generic code. Else, if f can be implemented via C's public interface, make f a non-member. If you can access everything in a class, what point is there to make it a member function? Make it a free function. You have everything you need. And only else, the last part, the last branch, make f a member function. This should help a little bit. It doesn't answer all the questions, but at least I feel it makes a very good point. Usually a lot of the things at top apply, especially you have everything in the public interface already. And the last resort is the member function. But I have learned the opposite. So who has learned the opposite? Be honest. Virtually everyone. Yes, this is a real problem. So I also learned the opposite. Why did I learn the opposite? Because the first thing I learned was Java. I started to truly program in the 2000s, and this was the decade of Java. Java was great, Java was wow. And Java has only member functions. And so this was quite natural. Of course we do member functions. This is what object-oriented programming is like, right? Unfortunately, it's not. It's like a disease to some extent. So I don't know if you believe me at this point, but if you do, please help spread the word. Please help to make better software. Please enable people to see object-oriented programming for what it really is. It's not putting everything into one class, or perhaps several classes. Yes, this is a real downside, but there is, of course, a remedy. Okay, but now most people are on my side, I hope. But there is still a couple of very, very tough guys. No, I defy this idea. I definitely don't want to have my member functions, because free functions are just backward and C-style programming. Oh yes, this is something I've heard so often. I don't use the standard library. It's so backward. It's so old-fashioned. Okay, I pack out the big gun. I pack out the big gun to also get the last of you. And I resort to the copy function. Now I take the copy function from the STL. And I'm asking you, is this truly backward? Is this C-style programming just because it's a C-style function, a free function? Is it? Well, most people that I talk to would say, yes, of course, it's a free function. But let's analyze it. Let's analyze it a little deeper. Let's use the solid principles. And yet again, the solid principles are the basic OO design principles. Copy adheres to the SRP. It does so because it, if at all, changes for one reason and one reason only. This is good. Yeah, so of course, when does it change? But from a design point of view, it can only be one reason. It also adheres to the open-close principle. Because from a design point of view, you never have to change the function. You don't have to modify existing code. You can always extend it. You need special behavior, specialize it, overload it, do something. You always add code, you add your types, etc. You never touch this function. From a design point of view, perfect. It also adheres to this interface segregation principle. You might have heard that all the algorithms are based on a minimum set of semantic requirements. It's the minimal set. This is the least coupling that you can have to some type, the least requirements you can impose on somebody. This is exactly what ISP is asking of us. It's perfectly adhering to this principle too. And last but not least, the dependency inversion principle. It is not depending on your types. Your types are depending on copy. Copy is asking you for a couple of operations. Yeah? You have to be able to increment the iterators, you have to be able to decrement the iterators, you have to be able to read from one type and write to the other type. Yeah? You have to implement the assignment operator. This is the dependency inversion principle. It adheres to 4 of the 5 solid principles. Which one is missing? Okay, rhetoric question. The Liskov substitution principle is missing. It cannot adhere to Liskov because it's a function, it's not a type. Liskov is about type substitutability. But all the iterators, the input it, the output it that you put into this, they could actually adhere to Liskov. And so I have a very nice set of 5. It's all 5 of the solid principles. No, copy is not backward. It is not old-fashioned. It's actually the best that you can do for solving this particular task. And it's definitely the best for us as C++ programmers, because we are lucky that Alexander Stetnov realized this years before the solid principles were even derived. I personally feel this is amazing. This is truly amazing. So, and if this does not convince you, not in the least, I simply cannot help it. So at this point, I'm again bold. Okay, to put it in the words of Scott Myers, there was never any question that the standard template library represented a breakthrough in efficient and extensible design. Yes, it is good. It is awesome. So, I'm bold again. I said this is an hypothesis. I'm bold enough to now make it your guideline. So, no homo hypothesis. From now on, this is your guideline. Prefer non-member, non-friend functions. Whenever you write software, think about it. Can this be implemented as a free function? If yes, and if it's beneficial, and it will be, make it a free function. All right. I hope it's convincing to some extent. I hope it's something they can live with. I know sometimes it's hard, and in reality, it's in all the companies, you only have member functions. Why should somebody now start with a free functions? I know the situation, but still it works. It works splendidly. Forward the people to this talk. If this doesn't convince them, they will never be convinced, probably. And so your mission from today on is to spread the word. Spread the word that free functions are not old-fashioned, that there is real value in them. And so remember, free your functions. Thank you very much. All right. I know I already took all the questions. I know.
Is it on?
Yes.
Okay. I have a question regarding partial template specialization for functions. Do you see a problem with that approach? Because it's not...
So it's a technical problem. It definitely is. Yeah? There is no partial specialization of function templates. It's not generally a problem, but yes, I know. From experience, there is no perfect solution for this. I would not say it's something that should prevent you from using free functions, on the contrary. Yeah, but there's always some workaround. Usually, so the argument why it doesn't exist is because there's overloading. But unfortunately, it doesn't always work. I am still looking for a perfect solution that I could present for all cases. I didn't find one yet.
Okay, I'm looking forward to that.
Hi, thank you for a very inspiring talk. But I have a question about encapsulation. Okay, it's too loud.
Yes.
You suggested to take the functionality out and then hide it in a CPP file so that it's not accessible on the interface from the header file, right?
So this was just to show you, this is how it was done in C years back. Oh, still done in C. I mean, they don't have classes with private.
Right, but I thought the idea was that this is safer because now no one can call it.
If somebody wants to call it, you can still call it. So you don't have 100% protection, but it's much safer. So somebody has to really work hard to not call this function.
Yes, but then you lose reusability because now have you hidden it.
There's downsides to this. Yeah, I just wanted to make the argument. In the private part of a class, you don't have perfect encapsulation. It's an illusion. This is all I wanted to say.
All right, thanks.
Yeah, very interesting talk. Thank you very much. I was wondering how would you go about organization with this? I think one of the reasons we usually tend to ever group things together in objects is not necessarily for performance reasons or because it's natural to do it in a language, but just because that's how we work as humans, right? When you have a fridge object, you expect there to be a sort function in the fridge object, and if you want to know what you can do with the object, you list all the functions inside the object. Quite often your IDE does it for you, and so you know what you can do with it.
Absolutely.
When you take your functions out of the object, this doesn't happen anymore for you. So you would have to find some other way to do this. And for functions that are not as generic as the ones that you showed, you would have to have a place to keep these objects that is outside of the object, I guess in your case, but not too far away. So where would you put it?
So, great question. I actually missed this. My advice is implement the free function because it's better. And eventually it might evolve into something bigger, generic, etc. The question is where to put it, how to declare it, such that people are able to find it. And this is a matter of organization, of structure. My suggestion would be, first there's a class with all the member function declarations, and directly afterwards you declare all the free functions. Forward declarations work fine. This is what you can also use. And then they're implemented in the same file, if it's a header file, or in the CPP file, depends on whether it's inline or not, whether it's template or not. Eventually, you'll realize, oh, this is a function that might reuse somewhere else. This is something that, okay, a second type can use. And then there's the question of how to organize the dependencies. There's no general answer, unfortunately. In standard library, the algorithms are in a separate header file. This is something that it could do. Sometimes it's just natural to keep it close to one type and just use it from the other type. I think the most important thing is to communicate this kind of structure. First all the member functions, then all the free functions. If this is widely known, then people will find them. And else there's one thing more that you can use, but I know people don't like to use it really. This is documentation. If the documentation actually explains this well, and for my library, for instance, I'm doing this, I'm explaining all the functions separately, member function and free function mixed, then this is something that people can also use. Look at the documentation, not necessarily only at the source code. I hope this helps.
Yeah, thank you very much.
Yeah, very briefly, one advantage I think you didn't mention is that with member functions you have to write const and volatile overloads and const volatile, and I think there's 48 at the latest count, and you can just do one with this.
Okay, it's always good if people add advantages. I'm very happy about this. Thank you.
What's your opinion about static member functions versus free functions as a starting point?
Okay, this is also a good question. The static member function as a replacement for a free function, you do not gain as much benefit from it. So my suggestion is to really make it a free function, prefer namespaces to classes as a container. In the namespace, it can be picked up by ADL. This doesn't work for the static member function. Also, you always have to qualify your static member function with a class name. This makes it very hard to use in generic code. So I vastly prefer the free function, but yet again, sometimes the static member function is just the right thing to do. So prefer the free function, sometimes use the static member function when you know this is better. Yeah.
Okay, and for private static functions, because that we use a lot.
Okay, again, it depends. So I assume you are the expert. You know, okay, I'm doing this for that and a reason. If you know that this is reasons that outweigh all the things that I said, please do it. I did not say never use the other stuff again. All right, thank you very much.